Okay, welcome back to Applied Behavior Analysis in Early Childhood. The current unit is Behaviorism. And first we're going to talk about a couple things to contrast with Behaviorism. So first I'd like to ask you, what is behavior analysis? I'll give you a moment to think about it. Well, behavior analysis is the scientific study of functional relations between behavior and environment. The goal of behavior analysis in general is to identify and characterize fundamental principles of behavior. So, what is applied behavior analysis? Well, applied behavior analysis is the application of those fundamental principles of behavior to socially significant problems. And it includes the technology derived from those basic principles. So, for example, the use of differential reinforcement to replace challenging behavior with improved communication, or the use of extinction to reduce challenging behavior. Those are examples of applied behavioral technology that has emerged from research in applied behavior analysis. And so, what is our basic approach? Well, our basic approach is science and experimentation. Right? So, we use, more often than not, behavior analysts use single subject design experimental methodology to experimentally evaluate functional relations between behavior and environment. So our basic approach is experimentation. Behavior analysis is a science, and applied behavior analysis is the application of fundamental principles of behavior discovered in behavior analysis to socially significant problems, and also the development of applied behavioral technology, useful for changing behavior, teaching skills, assessing functions of behavior, and so forth. So what is the philosophy underlying our science and our basic approach to science? Well, our philosophy is behaviorism. So behaviorism is the philosophy underlying our science and our basic approach to science. And there are different types of behaviorisms. Radical behaviorism, methodological behaviorism are two common types of behaviorism. And in general, the way to think about this is that a philosophy is a worldview. It's a way of looking at the world, looking at behavior. It's a way of asking questions about the world, how behavior works, and under what conditions. And it's a way of interpreting phenomena in the world. So behaviorism is not a science. It is not experimentation. Behaviorism is not behavior analysis. Behaviorism is not applied behavior analysis. Behaviorism is the philosophy that underlies behavior analysis and applied behavior analysis. So here are our objectives for this video part. The first is you'll be able to list philosophical assumptions of behavior analysis, then define and list some characteristics of determinism, then define and list some characteristics of empiricism. Those are two assumptions of behavior analysis. And then list some characteristics of inductive and deductive reasoning as they relate to empiricism in the study of behavior. And then in the next video part, we will discuss the other philosophical assumptions of behavior analysis in more detail. Beginning with objective 1, list philosophical assumptions of behavior analysis. Here they are. So in this slide, all we're going to do is list them. The first assumption is determinism. The second assumption is empiricism. The third assumption is parsimony. The fourth assumption is philosophic doubt. And the fifth assumption is pragmatism. Now, a mnemonic that I found useful for learning to quickly list philosophical assumptions of behavior is DE3P. So D, determinism, E, empiricism, and then 3 Ps, parsimony, philosophic doubt, pragmatism. Again, that's DE3P. So it'll be useful to have a flashcard where on the front it says DE3P, and on the back it lists these philosophical assumptions. And another useful flashcard would say on the front mnemonic for philosophical assumptions of behavior analysis, and on the back it says DE3P. So those could be useful. Alright, so let's look at objective number 2. We're going to now define and list some characteristics of determinism. Determinism. It's the assumption that events in the universe are lawful, orderly, predictable, and determined by physical causes. Okay, what do we mean by orderly? That are events in the universe can be patterned, right? And so there are patterns of events or phenomena in the universe out there to discover, and that there are forces that control or govern those events, and we call those and those are natural forces. We call those laws of nature, or when we're talking about behavior, we talk about fundamental principles of behavior, which is the same thing as a natural law of behavior. So this determinism makes this assumption that events in the universe are orderly and lawful, but also predictable, that you can predict events that are going to occur in the future based on information that you have now. And it's also assumed that these events are determined by physical causes. And that's important, because for us to be able to interact as physical beings, for us to interact with events in the universe, those events also have to have a physical basis. That is, they have to be determined by physical causes. Otherwise, they would be inaccessible to us through our senses. An implication is that because behavior is an event, then behavior is orderly, lawful, predictable, and determined by physical causes. And within determinism, it's assumed that determinants of behavior are phylogenetic variables, ontogenic variables, in the current environment. Ontogenic variables being the learning history, current environment being the SDs and MOs and that are available currently, as well as consequences correlated with those antecedent stimuli. And then by phylogenetic variables, we mean due to natural selection. Now, we also acknowledge, because we practice skepticism as scientists, practitioners, that some events and therefore some behaviors may not be determined. And this position is consistent with other basic sciences such as physics, which has adopted both classical and Newtonian mechanics, which are deterministic, and quantum mechanics, which is not deterministic. So other natural sciences have taken the approach that some behaviors or some events may not be determined, but in general we assume determinism. And that's okay. That's worked out pretty well for the natural sciences so far. Now, the assumption of determinism is sufficient to allow for a robust science of behavior in which we identify determinants of behavior through evaluation of functional relations between behavior and environment. All right, if we're going to use scientific methodology to identify functional relations between behavior and environment, then it has to be possible. There have to be orderly, lawful, predictable changes in behavior that we can discover. All right, so if behavior were not determined, then orderly, lawful, and predictable, then we couldn't have a science of behavior, because we wouldn't be able to modify the behavior. So I want to give you an example of how elements of determinism can be identified in an assessment used to determine the function of challenging behavior for the purpose of developing an effective intervention. So these are data from a study I conducted focused on treatment of challenging behavior. On the y-axis is responses per minute. On the x-axis is sessions. And the participant was a 4-year-old boy with autism spectrum disorder who was reported to engage in challenging behavior consisting of inappropriate vocalizations like whining or yelling, consisting of non-words or tears or crying, angry statements such as "I kill you," disruption like kicking feet rapidly, tensing of the torso as indicated by bending forward, tensing the hands into a cramped or fist-like position, stomping feet, hitting furniture with hand, and then self-injury, hitting one's tailbone or buttocks on the floor, or banging a head on the floor, or and also elopement, running to another room consisting of at least 5 steps away from the adult. This assessment, called a functional analysis, was conducted in the child's living room on the couch with his dad present, and dad video recorded the sessions, and then we collected data on challenging behavior by viewing the videos. The dependent variable, though, there is responses per minute, right? In this functional analysis, there were 4 test conditions and a control condition. And the logic underlying this assessment is that we can, what you do is you compare the level of responding. So for example, in this case, responses per minute in one condition, in one test condition relative to the control condition, another test condition relative to the control condition. And if there are elevated levels of the behavior in the test condition relative to the control condition, then we conclude that that condition identified a class of reinforcers that control the challenging behavior or that maintain the behavior. Okay, so for example, the tangible condition represented by the open square was a test for challenging behavior maintained by continued access to preferred tangible items. And in the closed diamond data path, we tested for attention maintained challenging behavior. In the closed triangle data path, we tested for automatic reinforcement of challenging behavior in an ignore condition. And then in the closed square data path, we tested for an escape function of challenging behavior. So as you can see pretty clearly inspecting this graph, that levels of challenging behavior were much higher in the tangible condition relative to the control condition. And challenging behavior was not elevated in any of the other test conditions relative to the control condition. So what we can conclude is that challenging behavior was maintained by access to high preferred items or activities, that is, tangibles. Now the pattern of behavior in the tangible condition and also the control conditions is clearly orderly, right? And if behavior wasn't lawful, that is, if there weren't natural laws that govern or control behavior, then it's really unlikely that this analysis would have been able to demonstrate experimental control over the behavior. Just notice that the behavior, if the behavior is controlled by the environment, and so each condition represents a certain environmental arrangement in which we were measuring the behavior, right? So in the control condition, the behavior didn't happen. This condition didn't happen. This condition didn't happen. This condition didn't happen. This condition increased, right? The responses per minute went up in the tangible condition. But then when we went back to this escape condition, the behavior didn't happen. The control condition, behavior didn't happen. So what are we doing here? In this functional analysis, we're actually controlling the behavior by modifying the antecedents and the consequences in the environment. We are showing that the behavior actually is controlled by reinforcement, which at this point is considered a fundamental principle of behavior, so synonymous with a natural law. Now also, these data demonstrate that behavior is a predictable phenomenon. In other words, by the time you got about right here in the functional analysis, and then you were going to proceed with collecting data in sessions 16, 17, 18, 19, 20, 21, it's pretty clear that you were at this point you could have guessed with confidence, what the next level of responding is going to be for the next square condition here, right? Or the next triangle, or the next circle condition. And up here, after these 3 data points, it was pretty clear that, hey, we can assume that the 4th data point is going to be approximately the same level as these other 3 if we hold the environment constant. That is, if this condition is exactly the same as this condition and this condition and this condition. So it's demonstrated here that behavior is predictable. And also that it's determined by physical causes, because the elevated levels of challenging behavior coincided only with the tangible condition, and the fundamental difference between the tangible condition and the other conditions was a contingency between challenging behavior and access to tangible items, and tangibles are physical objects. Okay, so determinants of behavior are phylogenetic, ontogenic in the current environment. And so these data are consistent with those assumptions as well. The current environment across sessions was manipulated to demonstrate different levels of challenging behavior, and this behavior was shaped up by a learning history, and learning from the environment is actually a skill that is passed on through natural selection. So the ability to interact with the environment in a way that the tangible reinforcers can control your challenging behavior is actually an ability that was selected by natural selection. So that's the fact that this child could learn through interactions with the environment and consequences is of phylogenetic provenance. And then identify determinants of behavior through evaluation of functional relations between behavior and environment. That was done here. It's a clear functional relation between challenging behavior and tangible consequences. All right, let's look at some ASRs here. So ASR number 1, the assumption that the world is lawful and orderly, therefore behavior is lawful and orderly, is A, pragmatism, B, philosophic doubt, C, empiricism, D, determinism, or E, parsimony. A couple more seconds. All right, I'll go ahead and close the poll. The answer here is determinism. ASR 2, the idea that behavior is due to physical causes is part of which assumption of behavior analysis? Is it A, pragmatism, B, philosophic doubt, C, empiricism, D, determinism, or E, parsimony? A couple more seconds. All right, I'll close the poll. Answer here is determinism. How do knowing, understanding, wanting, and expecting as explanations for behavior violate the assumption of determinism? Is it A, they lack logic or common sense, B, because they're difficult to measure directly, C, these phenomena lack physical properties that can interact with behavior, or D, all of the above? Couple more seconds. Alright, I'll close the poll. And the answer here is C. These phenomena lack physical properties that can interact with behavior. They have no quantitative characteristics. So knowing doesn't have a beginning, middle, and end. You can't count it. It's not an observable action that one can engage in, right? So because they lack physical properties, then there's no way that behavior can interact with knowing, understanding, wanting, and expecting. Objective 3, define and list some characteristics of empiricism. And then 4, list some characteristics of inductive and deductive reasoning as they relate to empiricism and the study of behavior. All right, empiricism. It's a practice and an assumption, so we use the term in both ways. The assumption of empiricism is that an understanding of the world is best arrived at through science, relying on our senses, sometimes aided by technology, because the world really is as we sense it to be. That's an assumption. Okay? What we smell, hear, taste, touch, see is how the world actually is. And therefore, behavior can be understood scientifically by using methods that rely on our senses and sometimes aided with technology. Now, empiricism in practice in relation to a science of behavior means that we define behavior in clear, objective, observable terms. So, for example, in the functional analysis that I described earlier, I define challenging behavior in very objective, observable terms, such as whining or yelling consisting of non-words without tears, or crying, including angry statements such as "I kill you." Disruption consisting of kicking feet rapidly, tensing of the torso as indicated by bending forward, tensing of the hands into a cramped or fist-like position. So this description of behavior is quite clear, quite objective, and it's in measurable terms. Those are all observable, measurable characteristics. So that definition I just described of behavior is consistent with empiricism in practice. We can quantify phenomena of interest. So there's the assumption that we can measure dimensional quantities of behavior: count, rate, latency, IRT, duration, acceleration. And we can repeatedly measure a phenomenon of interest over time. That's due to the fundamental property of repeatability. We can experiment by systematically manipulating independent variables, i.e., teaching practices or treatments. In the earlier example of a functional analysis, I systematically manipulated very specific variables. For example, in the escape condition, the child was presented with demand, and if and only if they engaged in challenging behavior, the demand was terminated for 30 seconds. In the attention condition, attention was withheld for the session until the child engaged in challenging behavior. At that point, contingent on the challenging behavior, attention was delivered. In the tangible condition, the experimenter took a turn with a high preferred item, and then if and only if the child engaged in challenging behavior, they were given access to the item. So those are very specific conditions that consist of the systematic manipulation of different environmental variables in a way that allowed for experimental evaluation of the function of the challenging behavior. And we can arrive at facts through induction, which we're going to talk about a little bit more in the next couple slides. Induction is also known as bottom-up scientific reasoning. Our confidence in what we understand through science is influenced heavily by replication. Okay? Generalized knowledge, knowledge that we can apply across circumstances and people and places and stimuli, is determined by the extent to which findings in the scientific literature are replicated. We have more confidence in the generality of a finding if the finding is replicated multiple times by multiple research groups, even if there are small variations in those replication studies. So, for example, we can repeat part of an experiment, an entire experiment, or repeat an experiment while varying conditions, such as participants and settings. Okay, so it's important that science replicate findings, and that we don't put too much confidence in a single study's findings. All right, that's all consistent with empiricism in practice, especially in relation to a science of behavior. Now, the practice of empiricism as it relates to behavior analysis is making decisions about interventions. And the decisions are based on objective research, theory, and facts. Such decision making should be influenced by objective research, theory, and facts to the maximum extent, rather than the advancement of one's career, their opinions, their beliefs, in other words, their personal bias towards a given, let's say, client or learner or student. Practicing empiricism means making decisions about how you teach or interventions that you deliver based on objective research, theory, and facts. Okay, ASR 4. The assumption that because the world is as we sense it to be, we can conduct experiments using observation, measurement, and systematic manipulation of environmental variables. A, pragmatism. B, philosophic doubt. C, empiricism. D, determinism. E, parsimony. A few more seconds. The answer here is determinism. And if you voted or you selected determinism, determinism is just the assumption that the universe is lawful and orderly, and therefore behavior is also lawful and orderly. Here, this ASR is asking you about observation, measurement, systematic manipulation. Those are key concepts associated with the empiricism assumption of underlying behavior analysis. ASR 5, the assumption that behavior is determined by the current environment, a learning history, and genetics. A, pragmatism. B, philosophic doubt. C, empiricism. D, determinism. E, parsimony. Give you a couple more seconds. Alright, I'll go ahead and close the poll. And the answer here is determinism. ASR 6, which is both a practice and an assumption? A, pragmatism. B, philosophic doubt. C, empiricism. D, determinism. E, parsimony. Couple more seconds. I'll close the poll. The answer is empiricism. ASR 7, arriving at facts through induction is due to which practice? A, pragmatism. B, philosophic doubt. C, empiricism. D, determinism. E, parsimony. Couple seconds. Alright, I'll close the poll. Answer is C, empiricism. Alright, we will actually end here and continue in video part 2 with deductive scientific reasoning.